Hey math fans, we're on Factoring Quadratics number 1. Let's get started. So what is factoring? Well, factoring is basically undistributing. We're going to undistribute a number, a variable, in order to get the solutions, the x-intercepts, the roots, the zeros, which are all the same thing. I have a graph to the right here. There are two x-intercepts in this parabola. Looks like one is close to -2 and the other one is close to +4. Now notice the x-intercepts are when the y value, or f of x, is equal to 0. So that's always going to be our first move, is we're going to set f of x equal to 0. And then we're going to ask ourselves, what value of x will make the entire function equal to 0? So I have another parabola here. First step again, set it equal to 0, because I want to figure out where does it intersect the x-axis. And then after a couple of different methods that we could use, we're going to come up with two sets of parentheses, or maybe just one set of parentheses, depending on the quadratic. But we're going to be setting those parentheses equal to 0, and then that way we can solve what are the x-intercepts, or the solutions, or the zeros, or the roots. They're all the same thing. This has x-intercepts at -2, 0 and at 4, 0. So the first thing I want to look at is something called greatest common factor factoring, or GCF factoring. What do these two terms have in common? And it's kind of obvious. We can undistribute the x. So we undistribute that x to the 1 power. We get x times the quantity of x plus 3. Our next move, even though you can't see it, but I want you to pretend like there's parentheses around the x. I want you to set the parentheses equal to 0. So we're going to have that x is equal to 0, and then x plus 3 is equal to 0, which if we solve for x, we'll get -3. So we have two solutions, 0 and -3. Those are going to be the x-intercepts. And here's a graph of the function. Here's another example. We're going to factor the function f of x equals 8x squared minus 4x. So what do they have in common? Well, they both have 4 in common. We could factor or undistribute a 4 from both of these terms, but they also have an x. So 4 and x, so in other words, we're going to pull out 4x, or divide both terms by 4x. We're undistributing it, which leaves us 2x minus 1 in the parentheses. Now we're going to set both of these equal to 0. Again, you can't see the parentheses around the 4x, but let's pretend like they're there. So we'll say 4x is equal to 0, and then also 0 is equal to 2x minus 1, and you get the answers of 0 and 1/2. If we take a look at the graph, the intercepts are at 0 and 0.5, which is 1/2. The next thing I want to take a look at is factoring by grouping. This is going to be the main way I want you to factor quadratic equations. Now notice this one's not a quadratic, this is actually a cubic expression, but the process is still the same. So I want you to analyze. Let's take a look at the first two terms. Do they have anything in common? And I'm looking at them and it looks like they have an 8 in common and x squared. So I'm going to actually do what we were just doing and pull out the GCF of 8x squared, which leaves me with the parentheses of x minus 2. Second two terms, they both have 3. I'm going to undistribute a 3 and I'll have x minus 2. Now here's the tricky part. If we think of 8x squared times x minus 2 as one term, and then 3 times x minus 2 as another term, technically they both have something in common, which is x minus 2. So we can actually pull out that GCF from both of them. So I'm going to pull out the x minus 2 from both of those. And then what do I have left? I have 8x squared plus 3x. I just undistributed the x minus 2. And that's it. That's your final answer. 8x squared plus 3 quantity times the quantity of x minus 2. Here's another one. Take a look at the first two terms. So that factors into x squared times quantity of x plus 1. And then the second one, I noticed they both have negative 5 in common. Now, I'm going to say that if you only undistributed the 5, you will get 5 times the quantity of negative x minus 1. Now, you need to have it match. Since they don't match, you're going to have to think, wait a minute, how can I get this to be just like, how can I get it to be the same as x plus 1? Well, you're going to have to factor out the negative with it as well. At this point, I can factor out the x plus 1, and then you're left with 7x squared minus 5 times the quantity of x plus 1. And that's going to do it for this section. We'll see you in class.